Web work, functions difference quotient, problem number 6. Problem number 5 we did in class, that was a rational function. This one is a radical function. Now, radical function is going to start out pretty straightforward. F of x is equal to radical 5x plus 5. So plug in a for x, and you get radical 5a plus 5. Plug in a plus h, and you're going to get 5 times a plus h plus 5 in the radical. And then your radicand here becomes 5a plus 5h after distribution. No more simplifying to be done here, so again, pretty straightforward. Even the numerator here, the subtraction, f of a plus h minus f of a, turns out to be pretty straightforward. You're subtracting radical 5a plus 5h plus 5 minus radical 5a plus 5. And again, no more simplifying to be done. Now, when you move to the difference quotient, which is dividing radical 5a plus 5h plus 5 minus radical 5a plus 5 divided by h, here's where things get a little hairy. Basically, when we are simplifying the difference quotient, we want to get rid of h in the denominator. All right, that's our main goal. And again, the payoff will come later on when you get to calculus level math. So in order to proceed on this problem, we're going to multiply by what is called the complex conjugate. Remember the complex conjugate, over here, we have a binomial of a plus b. That means the complex conjugate is equal to a minus b. And that's what we're going to apply here, because multiplying these together is going to result in something pretty interesting. So the reason why this is more complicated is because think of a being replaced by this radical, and think of b being replaced by this radical. So we're multiplying by radical 5a plus 5h plus 5. This should be a plus 5 in here. I miswrote that. That should be a plus. That should be a plus. I don't know if I made that mistake anywhere else, but if I did, I will adjust it. Sorry about that. Anyway, we have the same terms in the beginning, 5a plus 5h plus 5 plus 5a, radical 5a plus 5, right? Again, there's a minus here. So applying the complex conjugate, again, means writing the same two terms with the opposite sign in between. And multiplying this requires FOIL, right? We have to multiply top and bottom by the same thing because this is a fraction, right? So on the bottom, it's just going to kind of carry on through. H times the quantity, radical 5a plus 5h plus 5 plus radical 5a plus 5. That's going to be the same denominator all the way throughout. There's really nothing we can do about it. But the numerator, we're going to be foiling, right? So first times first. That's going to be radical 5a plus 5h plus 5 times itself. So that gets us the same quantity raised to the second power. We're going to get this radical 5a plus 5h plus 5 now times, right now going to the outers. So radical 5a plus 5. And that's going to result in here just multiplying those two together. Do not try to simplify this. Do not combine these radicals. You know, you can combine radicals through the process of multiplication, but don't bother, to be honest. It's not worth it, because you'll see what happens later on. Minus radical 5a plus 5 times radical 5a plus 5h plus 5, and that's what we're getting right over here. That's the inners. And then the outers is radical 5a plus 5 times itself, so we get that raised to the second power. Now, the reason why we multiply complex conjugates is so that we can get rid of the middles, because that's what happens, right? Look at when we combine like terms over here. These middle terms, let's cross it out with something a little bit lighter so you can still read through it. But these middle terms go away. Again, that's why I said don't bother multiplying it out or anything like that. It's not worth it. It's a waste of time to go through that, because those are going to add up to 0 anyway. So our numerator, which was very, very long, now becomes much, much shorter. Radical 5a plus 5h plus 5 raised to the second power minus radical 5a plus 5 raised to the second power. There's another mistake again with me putting a plus sign. So the numerator gets even better now as a result of the complex conjugate, which is that a radical raised to the second power just basically means that the radical's gone. 5a plus 5h plus 5 is now outside the radical because it got squared. Same thing with 5a plus 5 that used to be a radicand. It's raised to this radical raised to the second power basically means that this radicand is as is. In addition to that, let's use this here. This is a minus sign, which is going to have to get distributed into here. That's why this becomes a minus 5a, and that's why this becomes a minus 5, right? So remember that after you square this, right, there's still a minus sign in front of this polynomial. So I'll rewrite, actually, let's not be lazy. 5a plus 5h plus 5 minus 5a plus 5 divided by h times 5a plus 5h plus 5, which is inside the radical, plus 5a plus 5, which is also inside the radical. So what happens here is that we have distribution, and that becomes minus 5a minus 5. Now again, even nicer, even better, is that 5a minus 5a adds up to 0. 5 minus 5 also adds up to 0. So our numerator really becomes just 5h. Our denominator stays the same. Cancel out these h's because we did not distribute this h into here. Don't need to, right? Because we're going to reduce fractions, reduce our rational expressions later on. That way we want to leave things in factored form. And we get our result with 5 in the numerator, and then radical 5a plus 5h minus 5 plus radical 5a minus 5 in the denominator. And that is the difference quotient for a radical function.